Hey everybody. Today we're doing another linearization example. Suppose that we know that f of 0 is 2.4 and we're given the graph of y equals f prime of x. So just to be clear, this is the graph of the derivative of the function, not the function itself. We want to approximate f of 0.2 and we want to determine whether this is an overestimate or an underestimate. We're going to use linear approximation. Here's the formula. F of x is about equal to f of c plus f prime of c times x minus c. And of course, this is really just the equation for the tangent line to the graph of y equals f of x at x equals c. Bear in mind, this is going to be an approximation that is useful near the value x equals c. We already know that f of 0 is 2.4. That was given to us. So we're going to use c equals 0 here. We refer to the graph of f prime of x to see that f prime of 0 is 0.5. Now we're ready to plug in values to that formula that we have at the top of this slide. We get that f of x is about equal to 2.4 plus 0.5 times x minus 0, or, to say it more simply, 2.4 plus 1 half x. Now, in order to find an approximation for f of 0.2, all we have to do is plug 0.2 into that equation. When we do and simplify, we get 2.5. To determine whether this is an overestimate or underestimate, we notice that f prime of x is increasing between x equals 0 and x equals 2. In other words, on that whole interval between where we linearized and where we made our approximation. That means that f prime of x is going to be greater than f prime of 0 on that interval. Since the linearization uses the same slope, namely f prime of 0, on the whole interval, it's going to have to produce an underestimate at x equals 0.2. I think a picture makes this a little more clear. Let's use the graph from the previous slide, the graph of y equals f prime, to sketch y equals f of x. If we do that, we get something like this. You can see that the slope of the tangent line is going to be increasing near x equals 0. I've also drawn in the tangent line itself at x equals 0. That's our linearization. Since the f prime is increasing near x is 0, the graph of the graph of f of x curves upward away from the tangent line. The graph's concave up here. And so we can confirm visually that the linearization is going to give an underestimate near x equals 0.